Now, binomial theorem next. So to get started, we need a little bit of a definition. I don't know if some of you have seen this meaning, the meaning of this symbol before, called 3 factorial, for example. Means 3 times 2 times 1. You know. 4 factorial? Yeah. What's 2 factorial? Yeah, so that's 2. 1 factorial? 0 factorial? Ah, it gets them every year. It's 1 as well, so you need to be careful with that one. This button is on the calculator, right? Yeah, good. So, using that, next is this symbol. Guys, you looking up? Yeah. NCOR, also written as NOR, with brackets like that. And the meaning is n factorial over or factorial n minus or factorial. Now I'll give you an example with some numbers to make it clearer. So if I said 10C2, that would be 10 factorial on the top, 2 factorial here, and then the difference, 8 factorial. Yeah. And good, this works out to be 45, is it? Yeah. But your calculator has this button on it too. Can you all take a minute to find out where it is on your calculator? Yeah. Huh? On your one, that's where it is, yeah? Have you all found this button on your calculator? Now, it might look like this, or it might be like this. Although I feel like it's probably this one. Yeah? You found it? You all found it? Yeah. So what I want you to do, guys, what I want you to do is calculate the following for me. We'll say 5C0, 5C1, 5C2, 5C3, 5C4, and 5C5. So using your calculator, give me those 6 values. So first one's 1, 5, 10, 10 again, 5 and 1. 1, 5, 10, 10, 5 and 1. Yes? You all got that on the calculator, yeah? So you should notice that that looks familiar to Pascal's triangle. So this provides a quick way to get any row on the triangle. So if I want the 5th row, I can just calculate these 6 numbers. If I want the 3rd row for like cubic, it'd be 3C0, 3C1, 3C2 and 3C3, which I know will work out on the calculator to be 1, 3, 3 and 1. So this provides an even quicker way to expand. Even quicker way. Oh, let's have a look at some examples of making use of this. Oh, and this is called the binomial theorem, which is the name of the lesson. We'll have a look at an example. Okay, so let's pick a small one. Let's say something, what one did I do earlier with the was there a 2x minus 3y that I did? Was this an example we did earlier today? Yeah? So let's do this one again, but using the binomial theorem. So what we do, we'll write c 2x minus 3y plus c 2x minus 3y, c 2x minus 3y. How many times? 4 times. One more than the power. Okay. The c at the top is always the power. So in this case it'd be, I'll put it in green actually, there must be a 3 on the top of the c's. And again, you have flexibility. You can start at 0 or 3 at the bottom. So let's naturally start at 0. 3c0, 3c1, 3c2, and 3c3. Again, for the powers you have flexibility. You can start at 0 or 3. So we'll put a 0 on the first one. 1, 2, 3. Now I don't have any flexibility. What must I start with here? 3, 2, 1, and 0. So we, as an example, just as an example, suppose you want to calculate this one. What you would need to type in on the calculator, and I recommend using brackets to be safe, okay? So I would type in something like bracket 3c1 on the calculator like that, bracket 2, close the bracket, power 1, and then bracket minus 3, close the bracket, squared. And then what would I have for x and y? X power 1 and y squared, yeah. I'm taking this one just as an example. So someone can tell me please, what is this one I just did as an example? 53, is it? 54 x y squared. Okay, so, sure, let's finish it now for the other ones since we're looking at it. So the first one works out to be, if you were to type it in, minus 27 y cubed, then 54 xy squared. What's the next one? 2 squared is 4 minus 12. Minus 36? Is it? The third one? Person without a calculator? Many people with calculators. The next one is 36? Yeah. 36 x squared y, and then the last one is 8 x cubed. Yeah? Okay, let's do some more examples of how this is useful. Do we have that written down? Okay. Yeah, can we look at another example? Yes? Can I scroll down? Yeah? Okay, so look. One great advantage of this method is it lets you jump into the middle of your answer if you need to. So like I could say something like 5 plus x power 6, I could say then, what is the in this expansion, what is the coefficient of x cubed. So I'm not looking for you to do a full expansion. I'm just looking for you to jump to the part of the answer that has x cubed in it. Do you understand what I'm saying? Yeah, just the x cubed piece. So let's have a look at that. So we imagine that we've expanded fully. So we have dot, 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 plus, and we're just looking at the piece that we want in the middle somewhere. Okay, so I'll just leave a space. Dot, 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 dot. Okay, so I know it will be made up of 3 parts. It will have its c in the front, like it always does. It'll have a bracket, what will be in the first bracket? 5. And then in the second bracket, x. Now, and we don't care about the other terms, we just care about this single term, okay? Let's start filling in the numbers. So straight away, I know what this number on the upper part of it must be. It must be 6, because that's the power. Also, I know one of these straight away. Which one?
X.
Yeah. It must be cubed. Must be cubed because I'm asking for it. Yeah. Now you're thinking, I can see what you're doing. You're thinking what number goes here. Yeah, what is it? Yeah, now there's a shortcut to figuring out this number. If you look at the previous example, you notice how, well, maybe even the one before that might be a bit clearer. Oh, it's closed, sorry. Well, I'll use this one as an example. The powers always combine to give you the original. Yeah, so it's a time saver. So if this is 3, this one must be 3 because it should total back up to 6.
Okay.
What is the number down here?
3.
Yeah.
It's
The same as what?
the power.
Which power?
The first power.
Yeah, not the second power? I know in this case it doesn't matter, but the same as which one? The 5. Yeah. In fact, it doesn't matter. You just need to match this with one of the powers. So, okay, in this example, it obviously doesn't matter because they're both 3. But, you know, if this was, say, a 1 and this, say, was a 5, then this guy down here could be a 1 or a 5. You'll get the same answer. Now, you might say, well, why would I get the same answer? Because if you remember the triangle, I'll just draw it here. The triangle is symmetric. You know, the second number here from the start is the same as the second one from the end. So this one here, if this one is 4C2, C1, this one here is 0, 1, 2, 3, this is 4C3, they're the same on the calculator. In other words, I can put either number here and the answer on the calculator will be the same. And the reason it works out to be the same is because it's symmetric. You don't have to worry about it. Well, let's do another one, maybe one that's not so like this. Let's say this time instead we have, so the answer is just this piece here. That's the final answer. You can type it in. Yeah, the word coefficient means the number beside the x. So you don't need to give the answer in the answer, yeah. So in 2 minus x, 7, find the x cubed coefficient. Right, let's do this one together. So, dot, 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 c, bracket, bracket, dot, 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 dot. What goes in each bracket?
2
minus x. Okay, here? 7. And then we know one of the powers.
4.
Which?
Here, 4.
Yeah, well, this one is 3, and then this one must be then 4. And here, 4 or 3, you'll get the same answer. Okay, so the answer then is 7c4. Oh, thank you, I forgot about that guy there, didn't I? 2 power 4 minus 1 cubed. Yeah, the minus here. Yeah. And you don't need to write the x cubed. Can someone type that in, please?
Minus 560.
What is it?
560.
560? It's useful. Let me give you a short one to try, a little bit harder than this, and then I have one more example type to do. Can I scroll down a little bit? Yeah. So let's say, I say something like, okay. My question for you to try then is, find k if the coefficient of x squared in minus 2x minus k power 3 is minus 24. Okay, give you a minute to try that. So it's similar to the last example. Yeah.
When can I know when I use Pascal or Binomial?
Well, if the question doesn't say, you can use either. Obviously, if the exam question says to use one method, you have to use that one. But really, if they don't specify a method, just use whichever one is easier for you. Yeah. Do you have a preference? Do you prefer one? No? Doesn't matter? Okay, so if we look at this one, we have 3c something, minus 2 and minus k. Now, we know the power of the minus 2. What should it be? 2 here, which forces this one to be 1, and then this one here? 2 or 1, yeah. So that's the coefficient of x squared. And what should that equal? Minus 24. So with just a little bit of rearranging, you can get k is 24 over 3c1 times minus 2 squared. So that's 3 times, so this will be 2 then, in the end. Okay, did you write that down? You got that, yeah? Easy peasy? Okay, I have one more type of problem to have a look at, and then I'll let you practice them for a few minutes. Can we scroll down? Yep. Expand to x squared in descending powers. The term, let's say, 3 plus 2x 4. So in this question here, I want you to expand, but I don't want you to expand the whole thing. I want you to stop once you get to x squared. So actually this is shorter than the previous examples because you stop as soon as you get to the x squared term. Okay? So let's have a look at this one. So straight away we know we're starting off with a c, a 3, and a 2x. And straight away we know what number goes here. What is it? 4, and this one is 0. Now, you have to be very careful. It does matter now if you choose to start at 0 or 4, because of a key word in my question, descendant. So I want to be starting with the biggest x and going down. So what do I put here?
4.
I have to put 4, and then 0. And then the next one would be 4c1, 3(1), 2x cubed. And then 4c2, 3 squared, 2x squared. And why do I stop? Well, I've reached the square, haven't I?
Yes.
So this will be 2, 4, 16 x power 4, yes? 12 times 8, 96, is it? Yeah, okay. 2 squared is 4, 3 squared is 9, 36, 36 times 4c2, what's that please? And then it's finished. So it's actually shorter than the other ones.
Can you see?
How?
Divide by 2?
Divide by 2?
No, because the answer is not complete. The sequence is not complete.
Yeah, you don't know what the other guys have. I know that the last term will be 81. So they can't all be divided by 2. Yeah, you got that? Okay, so what I want you to do now for a few minutes is 1a, 2a, 3a, 4a, and 5a. So I will finish up at exactly 4 o'clock. So if you can just try these for 10 minutes. However, I think 3 of you have tutorials with Emer. Yeah? So you just make sure you write these down and to do them at home. So you 3 guys can go to Emer and then everyone else just got to start on these, okay? Let's see. Yeah, yeah. Just make sure you get those ones done at home. Yeah. Diana? Oh, there you are. a sec. Let me see. I got this. Where's? Oh, there you are. Joshua. Oh, there you are. Mohammed Omar. Oh, there you are. You're speaking Arabic right beside me. Come on. La. Oh, so I've got a full house then. Right. Which part now? Yeah, but what's the question? The minus 2 is because of that 2. Ah, so how do I know which one gets the 2? Because the coefficient of x squared, the 2 must be on the one with the x. I think perhaps so. I think that should be a plus. I think the minus is only on the k. Is it? Let me see. Which one? That's the one before, isn't it? Oh, I think, yeah, you copied it wrong. It's minus 2x minus k. Yeah. So that is the same as that one. Yeah? You think you got it?
Yeah.
Yeah? Okay.
Why I already told before why